Hey guys, today's circuit is a audio electric field detector, and just ignore the stuff over here. It's just this circuit right here, and it's just a audio amplifier with a high impedance input. It's really all it is. Now, 2 or 3 years ago I made a video on my old channel, which is no longer up, but this was a more complex circuit. It had a JFET transistor preamp. It worked really well, really sensitive, but I wanted to see if I can reduce the circuit, make it more simplified, and I think I come up with something that works pretty well. So let's take a look at it here. I'm using the ubiquitous LM386 audio amplifier, and taking it from the input here, we have a 10K resistor and a 5 picofarad capacitor. That capacitor is pretty important. It acts as a low pass filter by shunting high frequencies down to ground. The reason for that is the circuit's so sensitive it might pick up its own output, and that'll just cause it to be unstable and oscillate, and it won't work properly. And I also added the 10K resistor. If you're playing with this and you have a little bit of static on your hands and on your body, and you touch that input, and it'll eliminate some of the amplitude of that, because you don't want to damage the input circuitry of the amplifier. And at very high frequencies it also works with this capacitor as part of the filter. And another very important thing is this is an inverting amplifier. When it's used non-inverting, it tends to pick up its own output and oscillate. So using it as inverting, it's not as bad, though it still can oscillate. So using all the filters is important in this circuit. And over here on the output, a little bit different from a normal audio amplifier, I have a series 10 ohm resistor, 0.7 microfarad filter capacitor. These two act as a low pass filter, blocking the ultrasonic frequencies from getting to the output and being picked up from the input. So it's such a sensitive circuit, you really need to take all these precautions. Another reason for this 10 ohm resistor here is it limits the output current somewhat, because I'm using the little 9-volt transistor batteries, and it helps the batteries last longer, and it still gives you decent output. So you still have your coupling capacitor to block the DC from getting to the speaker. You can use an 8 or 16 ohm speaker here. They seem to work pretty well. And you might even take the ground and also solder it to the metal frame of the speaker, and that'll act as a shield to help prevent the input from picking up the output. And make sure you twist the leads that go to the speaker. Again, another precaution of blocking that oscillation. And what else? That's pretty much it. Pretty simplified circuit, and it works pretty good. So now hook it up here and play a little bit. Okay, I have a battery hooked up. I do recommend only running from battery, because if you connect to the wall, just the electrical noise it'll pick up is just so strong. And I have it hooked up to this cheapo speaker here. And for a ground plane, I connected to ground this aluminum foil, and I'll set this calculator on it. This is a vintage mid-70s VFD calculator. And then we'll try this mid-80s vintage calculator. Radio Shack, actually made by Casio, I believe. I'm not sure who actually made this one. So what I'm going to do is pick up the electrical noise this thing puts off. So have the input wire near the calculator, and I'll turn it on here. Okay, that was interesting. And this is exclusively solar powered. Since they use far less electricity, it may not pick it up as well, but you can already hear it. If I get that wire close enough, I'll just set this calculator there. That holds it down. $69. Where's the factorial key at? Well, that's interesting. That's electrical noise put off from calculators. Okay, let's try a few more things here. I have my wristwatch. These, I know these things don't put out much electrical noise, but we'll see what we can pick up. It's too much AC noise in the background, though. There's a little bit. Let me try the Indiglo light. You can pick up some. Here's an extension cord that's plugged in. Well, I can tell it's wired right because the smaller hole here is hot and it is loudest. So yeah, you can pick up the live AC without even touching it. And finally, I'll set this camera on here and see what it sounds like. Well, out in the car now, parked under these 450 kilovolt high voltage lines. Let me see, it's really making this thing go crazy. I shield my hand over the wire, it quiets down a bit.
Thank you for watching this John Audio Tech video production. Please stay tuned for some more upcoming videos. Until then,